Okay, here's a statement that you need to know as far as working the next problem that we're going to work. The velocity of a moving object is a vector because velocity has both magnitude and direction. So the magnitude of velocity is simply thought of as speed. Okay, so when you're asked about the magnitude of velocity, then that's going to just be magnitude in that case is just also thought of as speed. Okay, so in this example, you have a jet that is flying on a bearing of 65 degrees at 500 miles per hour. Okay, so based on what I had just told you, of course this is speed, so that's going to be the same concept because we're talking about velocity here as magnitude. Okay, so like 500 is going to be end up being your magnitude. So you're asked to find the component form of the velocity of the jet. Now you've got to remember that bearing is the angle measured clockwise from due north, and there were some things that we did earlier concerning bearing. So first of all, let's just get us a sketch of this situation that we are dealing with. So you're going to have like your north-south line and your east-west line. Now, bearing is 65 degrees, and bearing is measured clockwise from due north. Okay, so if this is due north, and you've got to go clockwise, go the direction of a clock. So you're going to go 65 degrees from here around to here. So this vector is going to represent this situation. But this is the part that is the 65 degrees. So when you drawing things in standard positions different than drawing it concerning bearing, okay? So again, it's measured clockwise from due north. So if this is 65, then this is going to be 25. Because actually when we go to work the problem, you're going to need to use the 25, okay? Now, you're just simply asked for component form. All right, so we know that magnitude, based on what I had told you about magnitude versus speed, that's going to be your 500, and we know that our angle is 25 degrees. So like in the formula that we've been using, where we've had the magnitude times cosine theta and the magnitude times sine theta, the same formula here, this angle is measured from the positive end. So like on this example, it was measured from the positive end of the x-axis around. That's why I said when you go to work this problem, you're actually going to have to use the 25. Now, you're just simply wanting the component form. So your component form is going to be the magnitude of this vector, so I'll just call it V, times cosine theta, that'll give you your first component, and then magnitude of V times sine theta. All right, so substituting in what we know. Well, the magnitude's 500, and we know that theta is 25 degrees. Of course, in here, magnitude again is 500, but now I'll have sine of 25 degrees. Now, entering this into your calculator, so you'll have 500 cosine 25, and I'll just round this to 1 decimal place. I typed that in my calculator wrong. Hang on a second. Okay, so 500 times cosine 25. So that would be about 453.2. Okay, and then the 500 sine 25, that's going to be about 211.3. Now, what do these numbers actually mean? Now, if you remember back earlier when I first gave you this, This was referred to as your horizontal component. So this part is the horizontal component. And this is the vertical component. Okay, so what we have here, if this is the horizontal, that means that this jet is going 453.2 miles per hour, and it would be toward the east, okay? Because, of course, if this is north, then what we have over here is east. So we're in this northeast region, but it just means like the horizontal movement of the jet is 453.2 miles per hour, okay? So this would be east. Okay. And this being the vertical component, and of course since we're in this northeast region, then direction-wise that would mean north. So that means the north movement or speed of this jet is 211.3 miles per hour. So that's just actually what those numbers end up meaning.